Decision making is a process of making conscious choice between two or more alternatives, producing most desirable consequences, benefits relative to unwanted consequences, such as costs or damages. Here I would like to add that if there is only one alternative, there is nothing to decide. So when we have more than one alternative, only then we can talk about decision making process. For managers, decision making is an essential part of planning. Decision making and problem solving are used in all management functions, although usually they are considered a part of planning phase, in simulation, in optimization, and in risk informed decisions. Alright, uh, decision making can be classified under the conditions of certainty, such as you want to use maybe linear programming, decision making under risk would involve expected value, queuing theory, decision tree, and simulation. Or uncertainty, decision making under uncertainty would be expert judgment. Hurwitz approach, modeling uncertainty using data and game theory. Let's talk about decision making under certainty. So, decision making under certainty implies that we are certain of the future state of nature, right? In our model, this means that the probability of the future is known. Complete and accurate knowledge of outcome of each alternative we have in that decision making process, and there is only and only one outcome of each alternative. If the outcome if the outcomes are known and the values of outcomes are certain, so then the task of decision maker is just to compute the optimal alternative or outcome with some optimization criteria in mind. So for example, if the optimization criterion is least cost and we are considering two different brands of a product which appear to be equal in value to you, one costing 20% less than the other, then all other things being equal, you will definitely choose the less expensive brand. Um, Linear programming is one of the techniques for decision making under certainty. this table here shows the payoff table or decision matrix. So our decision will be made among some members M of alternatives identified as A1, A2, A3 running till AM, right? There may be more than one future state of nature represented by capital N. So the model allows for small n different futures. So n1, n2 up to n small n. These future states of nature may not be equally likely, but each state nj will have some known or unknown probability of occurrence pj, since the future must take on one of small n value of nj, right? And then we can say that the sum of small n values of pj must be equal to 1 because this set of all probability values are summed up to 1. The outcome here, the outcome that would be or payoff or benefit gained will depend on both the alternative chosen and the future state of nature that occurs. So for example, if you choose state or if you choose alternative AI and state of nature nj takes place uh, with a probability of, let's say, pj, the payoff will be outcome this one here oij. A full payoff table will contain m small m times n possible outcome. So let's consider a very simple payoff table. We have three alternatives here: bond, stock, mutual funds, and they are called our decision alternatives. They are the options available to the decision maker to choose from. In the columns we have the economic conditions. Since this portion is not in control of the decision maker, we call them as state of nature or outcomes, and the values in the table are called payoff. So payoff could be profit, cost, distance, time, among others. For example, someone has got one hundred or let's say $1,000, and he or she would like to invest it for 1 year. The return on each investment depends on the market behavior for that time period of 1 year. So here someone suggested that you have three potential investments: bonds, stocks, mutual funds. So that person would like to build a payoff table to basically help in the decision making process. So when economy is growing, after investment of $1,000, he is gonna get, let's say, $40 per year or per month. $70 if um, he invests in stocks, and he's gonna get, let's say, $53 had he invested in mutual funds. For stable economy, $45 for bonds, $30 for stocks, and 45 dollars in mutual funds. If economy is declining, he is going to get $5, minus 13 in case of stocks, and minus 5 in case of mutual funds. And he or she cannot just directly say that growing stocks is the best one, because there is a negative penalty, even though reward is more. But the future information regarding future is uncertain, so you don't know that whether economy will be growing, will be stable, or will be declining. So first approach is Max approach, and it's an optimistic approach. Here you are assuming that everything will go well, right? And then what you are going to do using this method, you will choose the alternative with best possible payoff. So let's say for bonds, best payoff is 45. For stocks, best payoff is 70. For mutual funds, the best payoff is $53. And out of 45, 70, and 53, 70 is the best. So if I am following this Max approach, the decision would be to invest in stocks. Maximin is a conservative approach, and here we will choose the best out of worst. So you can think, okay, if anything can go wrong, it will. And the worst of each one here, it's 5, minus 13, and minus 5, and then you choose the best of the worst possible pay off offs, so which is 5, right? On the basis of Maximin, invest in bonds. Let's talk about Minimax regret approach. So we choose the alternatives with the minimum of all maximum regret across all alternatives. Here regret is best payoff minus payoff received. So for example, if the economy is growing, the best payoff would be 60, and that is in stocks here. And let's say if we invested in bonds, then the regret will be best payoff 70 minus payoff received, 70 minus 40, which comes out to be 30. So if we invested in stocks, then the regret will be best payoff 70 minus payoff received 70. So 70 minus 70 is 0. And if had we invested in mutual fundings, then the regret will be 70 minus 53. 70 is my best payoff, and 53 is my payoff received, and hence the regret is 17. And here I will draw the regret table. Next step would be to choose the minimum of all the uh, regret values. So first of all, I need to choose maximum values in this table. So that is 30, 18, 17. Once I have this regret values, next step, as I mentioned, would be to choose the minimum. And here in this particular column, my values are minimum value is 17. So here, if I'm following minimax regret approach, the best decision would be to invest in mutual funds. Next one is equally likely approach. So here what we are doing, we are taking average of um, each alternative. So here let's say 40 plus 45 plus 5, whatever the value is, that's 90 divided by 3. So this value is 30. Then 70 plus 30 minus 13, I'm gonna add, divide it by 3 because n, small n here is 3. Mutual funds, 53 plus 45 minus 5, and I'm gonna add, then divide it by 3. So next would be to take the maximum in the averages. So it's going to be 31, and if I'm using the equally likely approach, then I need to invest in, or the investment decision should be mutual funds. Next one is Hurwitz realism, Hurwitz approach, and in this approach we choose the best weighted average payoff based on alpha. The coefficient of realism alpha is chosen by the decision maker, and its value is running values between 0 and 1. So the formula here is alpha multiplied by best outcome plus 1 minus alpha multiplied by worst outcome. So for bond, best outcome is 45 multiplied by value of alpha, which is 0.3, plus 1 minus alpha, which is 1 minus 0.3, which comes out to be 0.7, multiplied by worst outcome, which is 5. So the value is 17.0. I'm gonna do the same procedure for all alternatives available, and here I'm going to choose the maximum value here. So it's going to be, decision will be invest in bonds. Class discussion would be on which one is the best method. Like if you are um, suggesting someone that which one method should they use, so I would recommend that every um, methods got benefits and of course disadvantages. So what, as an engineer or as a manager, your job is to help in decision making process, not make decisions. So let's leave the decision making process to the decision maker. Your job would be to, okay, represent all the scenarios in front or to the decision maker and let them choose that which method they want to use. And because when you are summarizing all the scenarios and showing results of all the scenarios, this basically you are helping decision makers in this decision making process by giving them information and knowledge to help them in making risk informed decisions.